One of the beautiful things about math and algebra in general is that algebra can be reflected in a whole slew of different ways. So algebra is everywhere, math is everywhere, and we just don't realize the extent to which math guides and directs the world we live in. For example, if I have a sequence of consecutive numbers, a consecutive number is a number which seeks to which is right after itself. So for example, I'll take the number 1, and I'll take the number 2, I'll take the number 3, I'll take the number 4. These are consecutive numbers because they come right after each other. Now you can also say consecutive numbers 121, 122, 123, and so on. And the key is defining what a consecutive number is it comes right after the next one. So if I add 1 to the next, that will get 2. If I add another 1 to the next, that will give 3, and so on. You can actually take the pattern of consecutive numbers and algebraically express them. So what if I were to say, well, I have some number, I'm going to say it's x. If I wanted to add the number after x, I would say this is the first number, x, and then I would add the next number, x plus 1. And this makes sense because what if my number x is 2? 2 is my first number, we'll say, and I want to add 1 to x, and it gives me 3. If I want to add the next consecutive number, I can say x plus 1, but x plus 1 is just 3. I don't want 3, I want 4. So I have to add one more number to this, which if you can say is x plus 2. So consecutive numbers can be expressed algebraically in this format. And what you can do with this is you can use consecutive numbers to solve various equations. Now what if, for example, instead of saying I want to start at 2, the number could be some unknown number, saying 2 consecutive numbers together, and I multiply them together, and they'll equal 45. Today we're going to talk about how can we apply equations using what we talked about in the last lecture about variables on both sides. How can we use these two concepts together to understand real-world problems? Now, we're not only going to talk about consecutive numbers though. Applying equations also covers information like the distance equals rate times time equation. You will use this over and over and over again when it comes to algebra and pre-algebra. Other equations that you might find are the part equals percent times the whole. And so on. Multiple equations in which the world we use these equations over and over and over again. So let's take a whack at applying some equations and seeing how this works. So the rules of algebra dictate that whatever you do to one side, you have to do to the other. And second, if you want to solve the equation or the algebraic equation, isolating x or getting x on its side alone will solve it. We're going to introduce a new rule of algebra today, and I think this is the last one for at least the time being. Is accurately represent the problem. Don't accurately resent the problem. Accurately represent the problem by drawing or representing it in some way. Now, there are actually a whole bunch of ways that we can use to accurately represent the problem. So, for example, drawing a diagram might be an example. Or you can draw a picture about it. How does the problem expressed as a picture? Number 3, what you can do is you can draw or rewrite the story. Number 4 is to summarize the story. Number 5 is to give it a shot and go for it and just see what happens. And finally, number 6 is to read the problem over and over and over and over again. Now these different strategies will help you as you figure out how to apply the problem. And the reason being is a small part of math is computation when it comes to computing problems. A bigger portion of math is knowing what type of equation to set up for. And so your ability to imagine equations to the world and to apply them to math is where you will see the real beauty in math. For example, if you're a biologist and you say, hey, I see all these trees here. I see this forest, this beautiful forest with a whole bunch of trees. I wonder what the rate of rainfall has to do with the growth of trees. Or maybe you're a computer technician and you say you want to calculate some random number. What is the likelihood that this random number will be selected? Or maybe you're just a student and you're trying to figure out, hey, if I were to try to figure out the average amount of homework that I had to do per day, you could figure that out too. So part of the beauty and wonder in math is figuring out the equations that express these real world problems. This is where we begin to see the beauty in math, and people can appreciate the world more effectively because they see the beauty in math. This is where the wow factor comes in. If you make a musical instrument, for example, you can actually calculate the pitch that the musical instrument will emanate or produce based on the length of the pipe, for example. That's some of the beauty to math. And that's where some of the enjoyment comes as well. And you can begin to enjoy math more effectively when you're able to set up and apply these equations. So let's take a look at a couple examples here and try to figure out how can we apply these rules, these principles of applying equations to solving something like a word problem or a real world example or something of that nature. Our first example is to find a number such that 5 times the sum of that number and negative 3 is 3 less than the opposite of that number. Now the first thing you probably think about when you look at this problem is, why in the world do I need this? How in the world am I ever going to be sitting around and say, oh no, I need to figure out 5 times the sum of a number that is negative 3 less than the opposite of that number. And to be honest, you'll probably never use this exact type of problem in the real world. But what this problem does is it allows your brain to start thinking in terms of applying equations. So that when you're in biology and trying to figure out the rainfall, when you're a student trying to calculate the average amount of homework, when you are a professor trying to average out the student grades, when you're doing real world problems, it begins to help you think in a way that helps you to reflect and consider transferring English to math. So let's figure this out. So it says find a number. If you underline, it'll help you. What is a number? We don't know what the number is. It wants us to find what this number is. So we're like, hey, this is x. Some people say n because n stands for number. Such that 5 times, oh, we know there's a 5 there. The sum, it says the sum of something, so I gotta put a plus sign of that number. Okay, so 5 times the sum of that number and negative 3. Okay, so we know it's 5 times something, and we know there's a sum there, and we know there's a negative 3 there, so it starts getting confusing. So let's try again. Well, we know x is a number, and we know that there's a sum of this number and negative 3. But they're not actually summed together, they're actually subtracted together. And then, let's try this again. So we know, find a number such that 5 times the sum of that number. Well, n and negative 3. But we know it's 5 times that. Is almost always stands for equals. So when you see the is, you'll just pop an equal sign in there and continue. 3 less than the opposite of that number. Well, what's the opposite of some number? Well, the opposite of some number is going to be negative n. And it's 3 less than that, which means you're going to take negative n and subtract 3. So now that we have our equation here, let's read through and see if that works. Find a number such that 5 times the sum of that number and negative 3, so far so good, is 3 less than the opposite of that number. So it looks to me like we've set up the equation accurately. So now let's solve for n. So 5 times n is 5n. 5 times negative 3 is negative 15. And this equals negative n minus 3. Well, let's add n to both sides. Isolating n, so 5n is 6n. And I'm going to add 15n both sides too. Let's just do that all in one step. So that's going to be equals negative 3 plus 15 is going to be 12. So 6n equals 12. N equals 2. So this is a challenge because you're trying to figure out what some number such that 5 times the sum. You have to translate this from English to math, and the concept and the ability that you'll have to translate English to math will give you a huge leg up on standardized tests, which, standardized tests are one thing, but it'll also give you a huge leg up in calculating real-world problems. Example number 2 says the sum of two consecutive integers is 173. Find the integers. Now, as we talked about before, an integer can be expressed as x and x plus 1 and x plus 2 and x plus 3 and so on. So what we're doing here is we're trying to find two numbers right next to each other. The sum is adding. So I'm trying to find the sum, addition of two numbers next to each other. So one number, we don't know what the number is. But this number plus a number right after it, because consecutive integers is a number right after it, it's going to be x plus 1. And that equals is, and is almost always an equal sign. So is 173. 173. We need to find what the integers are. Now, once you get to this point, you've set up the equation. Solving it is not quite as hard because x plus 1 equals 173. So this is 2x plus 1 equals 173. Let's subtract the 1 from both sides, and that gives us 2x equals 172. And if you divide 172 divided by 2, you're going to get x equals 86. So the first number is 86, and the second number is the number right after that, which is 87. And if you add these two numbers together, 86 and 87, get 13, carry the 1, 16, 17. And in fact, these are two consecutive integers that add up to equal 173. So let's do one more example here. Let's find three consecutive odd integers such that 3 times the third is 2 more than 5 times the first. Now the first inclination is, whoa, what in the world does that mean? Well, let's start breaking this up. We want to find 3 consecutive odd integers. So we're not just trying to find 3 consecutive integers, because a consecutive integer would be 1, 2, and 3. We're looking for consecutive odd integers. So this will be 1, and then 3, and then 5, for example. Now if we wanted to express this mathematically, we could say, well, let's say the first answer is 1. If you want to add to go to the next integer, I'm going to add 2 to it. So it's plus 2. So the next number will be x plus 2. And then the next number, you'll add another 2 to that, which will be x plus 4. So consecutive odd integers. Now remember, even integers can be the same thing too. If you start with a 2, you wanted to go to a 4, you'd still add 2 to that. So even and odd, it's a different starting point. So we have this part. We know that the integers are here. So x plus 2 plus x plus 4. But there's more, such that 3 times the third. Okay, so we know that the third number is 3. And then we'll take a look at the second one. Oh wait, they say 3 times the third is 2 more than 5 times the first. So this is which equals 2 more, so plus 2, and 5 times the first. So we haven't really used the second one. We're like, hey, we're missing this guy. That's okay. We'll just solve it because we'll figure out what the first one is. So 3 times the quantity x plus 4, because this is 3 times the third integer, is 2 more than 5 times the first. So let's solve this. First we'll distribute 3x plus 12. And then we'll say 2 plus 5x. Now we need to isolate the x. So I want this to stay positive. So I'm going to subtract 3 from both sides. I'm sorry, 3x. So 12 equals 2 plus 2x. Now I'm going to subtract 2 from both sides. This will give me 10 equals 2x. Divide both sides by 2, and x equals 5. So the first number is 5, the second number is 7, and the third number is 9. And I want to encourage you, this may be a challenge, but as you embrace the challenge and continue to give it a shot, you will continue to find your brain growing in strength and capacity to handle harder and more complicated problems.